Hey team, we're going to learn how to optimize images and dynamically resize them in an Astro app using Cloudinary. I'm Colby Fayok, and if this is your first time here, make sure you hit subscribe and click that little notification bell for future web dev content. Astro is a web framework that gives us the ability to build really fast websites by delivering little to or no JavaScript for your pages. It can pull in content just like most frameworks that you're used to using, but another cool thing about it is you can use really whatever tool you want to use in it. So whether you're a React fan like myself, or if you want to use Svelte or Vue or all of them, which I don't recommend, you can absolutely do that within Astro. And on the same topic of performance, we have images, where we can use Cloudinary to make sure we're delivering as performant of an experience as we can for all of our images, making sure they're optimized as small as they can be without being visually different, and making sure we're delivering the most modern format that we can for those images, including AVIF. The cool thing is we can also dynamically resize our images, so we can use cropping and face detection to make sure that we're not only delivering the smallest compressed image, but we're delivering the sizes and the crops and the aspect ratio, so we're only delivering the pixels we need to the browser. So to dive in, I'm going to get started with this npm create command right on the homepage. We're in my terminal, I'm going to paste that inside, and what it's going to do is Astro is going to walk me through some steps that it's going to take in order to build my site, where first we want to tell it where we want to build our project. So I'm going to say my Astro CLD application, and then we can choose what template we want, where we can choose really a lot of these, but if you want to follow along, I'm going to use a portfolio because I know that it has images in it that we can update to use Cloudinary so we can see what we're actually getting. So I'm going to select portfolio, where it's now going to copy down those projects for us. We can also tell it, do we want to install the dependencies? And yes, I do want to install dependencies. So it's going to also prepare the project for us so that we don't have to do anything beyond this build step, rather than just simply run the application and get productive. But once our dependencies are installed, we can optionally initialize a new Git repository, which I'm going to do as well. And then we can decide if we want TypeScript or not, where I don't like to use TypeScript. I haven't dove too deep into it yet, so I'm going to say I prefer not to use TypeScript. But if that's your thing, you can totally use strict or whatever you want. But I'm going to say I prefer not to use it. And the rest is a go. And all we need to do now is navigate into my Astro CLD or whatever your project name is and run npm run dev. But that's going to start a new local development server, where once that's ready, we can go ahead and click that and open it up inside of our browser. And once it loads, we can see we have our new Astro app. Now getting started, we're going to head over to the About page if you're following along, where we can see we have this image embedded on the page, and this is what we're going to use as our example. If we look inside of our code editor, we can find this page by navigating to Source and then Pages, where we'll find that about.astro. And then if we start to look through, we can see that this page, if you're not familiar with Astro, might look a little different to you, where at the very top we have these lines that separate where we can actually run and import JavaScript. But then we can see we have our HTML document, including the head, some styles, and then we start to get into what you would typically feel like when you're looking at something like a React document, where we have our HTML and we have the dynamic bits that we can use to build our page. Now, just as a quick note, if you don't have it already and you're using VS Code, you can head over to the Install tab, where you can find the Astro language support. That way you can get all the nice syntax highlighting for your Astro components. But now we can find this image where we can actually start to dig in. So what we're going to do is we're going to first create an image component. That way we're wrapping and replacing the original image tag. That way we can define everything we need, like the Cloudinary configuration, in one place and use that inside of our entire project. So I'm going to open up the components directory, and inside I'm going to create a new file called cldimage.astro, where the very first thing I'm going to do is I'm going to actually define that image, where we're going to be able to add all the props there, but we want to actually be able to pull those props in dynamically. So we have our image tag, but then if we go to the top and we add that separation for those lines, we can start to run our JavaScript, where the very first thing we want to grab is the Astro.props, which is going to contain all of our different props. Now, for now, we can actually just spread those out on the actual image tag. That way, any prop that we pass in, such as the source, width, and height, just get automatically applied. But let's also add the loading equals lazy to make sure that we're always loading our images lazy. But if someone wants to override that, they can do so inside of the Astro props. But next, what we want to do is we want to actually define our props and the types that go along with them. So I'm going to specify interface props with a capital P. Then inside we can start setting what our props are going to be, such as our source, which is going to be a string. I'm going to duplicate that a few times, where we have our width, which is going to be a string, our height, which is going to be a string, and then finally we have our alt, which is also going to be a string. Now at this point, this is enough to get started, so let's head over to about.astro, where at the very top, I'm going to go ahead and clone down this import statement. I'm going to say I want to import CLD image from components CLD image. And all we need to do is scroll down to that image tag and replace it with our CLD image. Where the only thing that this is missing now is an alt, so let's add our alt value, and let's say shoes, since we know it was a picture of sneakers. But now when we look inside of our browser, if I actually try to inspect this element, because it doesn't look anything different, we can see that we do have that same image tag, but this time we're adding the loading lazy, which we know that that means it's working, as well as our alt, because we didn't have those on the actual image element before we set up this new component. So next, we want to actually start to install and set up our Cloudinary SDK. And to do that, we're going to use the front-end SDK for JavaScript. And technically, we could probably use the Node SDK if we wanted to, but there are some caveats in how things are going to actually get processed, and it might not work for future implementations. So I'm going to go ahead and just stick with the front-end JavaScript SDK, the URL Gen, because I know that this is going to work. So I'm going to go ahead and click Getting Started, where we can see down here, I have npm where npm install my Cloudinary URL Gen. I'm going to go ahead and paste that in my terminal, where it's going to now install that dependency, where once it's installed, the only thing left for us to do is actually import and configure it so that we can start to use it. To do that, at the top of my CLD image component, I'm going to first import Cloudinary destructured from @Cloudinary URL Gen. Then I'm going to create a new constant called CLD, which I'm going to set that equal to a new instance of Cloudinary, where I'm going to specify the cloud property, and I'm going to say my cloud name is equal to my cloud name, which I can find right at the top of my dashboard, where under cloud name, I can click the little copy button. Where inside of my code, I'll paste that right in, and now I have my Cloudinary configured. So ultimately what we're going to do is we're going to take the source that's passed in as a prop, and then we're going to pass that into Cloudinary before we actually pass it into the image tag. So to start, I want to actually pull that source out of the props. So instead of passing in Astro props as is, I'm going to say constant, I'm going to destructure my source, and then I'm going to actually spread out the rest of the props onto a props object. I'm going to say that's equal to astro.props. Now down on my image tag, I'm going to remove the Astro from the props so that the rest of the props still get passed in as is. But now I'm going to create a new let variable, and I'm going to call that CLD source. And I'm going to set that equal to cld.image, where I'm going to pass in the source to that image method. Now finally, to actually use that CLD source inside of my image tag, I'm going to say source is equal to, I'm going to pass in CLD source, but then I'm going to chain on to URL with all capital letters. Now, before we can jump into the browser, there's one more thing to do. And because we're actually currently using a remote image to pass into Cloudinary, we need to use what's called the fetch API, meaning Cloudinary is going to source that image from a remote source instead of loading it from Cloudinary itself. So I also need to say cld source.set delivery type. I'm going to set that to fetch. But now when I look inside my browser, we can see that I'm loading that same image, but if I look inside of the image tag, we can see that we are loading it directly from Cloudinary. Now this is working really great, but what if we want to load images from our actual Cloudinary source, where because we're hard coding the fetch API, this is going to expect it to be an external URL. If I head into my Cloudinary media library, if you just created a new account, or if you have an older one, you should be able to see that you have some sample imagery in here, where here I have CLD sample. And if I actually go in and start to manage this image, I can see right at the top left that I have my public ID, which is going to be my identifier for how I can source this image. Now, if I head back into my application and I update the source to actually include CLD sample, we can see as expected that it's not going to work because it's trying to fetch that as if it was a URL. But inside of our CLD image component, how about let's say if our source starts with https:// we're going to say that we want to set the delivery type to fetch. Now, this is kind of just a naive way of doing this. This isn't going to handle all use cases, but for our purposes, this is going to work perfectly fine, where if it sees that it's an external URL, it's going to set the delivery type to fetch, otherwise nothing, and then we can source it from Cloudinary. And we can see right away when we get back to the browser that we have our image and it's embedded inside the page, and we're sourcing it directly from Cloudinary. Now, part of the benefit here that I was talking about is that we want to optimize these images, right? If I head over to my network tab and I look at the image, we can see that I'm currently loading it as a JPEG at 478 kilobytes in size. Now, that's not going to give us any performance wins, right? But what we want to do is we want to set this up to automatically optimize it, both with a modern format and with the compression that we were talking about, so that we can get the best results that we can. Now, this is going to be really nice, short and sweet. All I'm going to do is specify format. I'm going to set that to auto, and I'm going to say I want my delivery to be Q_auto, where format auto is going to specify f_auto in the URL, which just says I want to automatically determine what format to deliver. And then I have my delivery, which I have Q_auto, which is saying I want to automatically determine the best compression I can use without sacrificing quality. But now as soon as that page loads, we can see our image, which looks exactly like it did before, but we can now see over in the network tab that we're now serving that as an AVIF, and it's a huge reduction in size. It's 183 compared to the 400 and some kilobytes that we saw before. Now let's take this a step further. If we look at this image, and again, if we actually inspect it, we can see what's happening is it's resizing depending on the size of the page, but we can see that at a certain point, it actually gets cut off. Now that's not really doing any of us justice. Now let's take this a step further. If we look at the image on the page, we can see that as we resize, it's going to change at a certain point where there's a max height on that image, where we're not really doing this picture any justice, where they start to get completely cut off at a certain point. So what can we do both to save the pixels so that we're not shipping that huge image on desktop, and so that we can actually position it correctly so that their face isn't getting cut off, making for a bad result for the experience? To start off, we're going to resize and crop this image to the width and height that we actually have inside of our image component specified. And to do that, if we head over to the CLD image tab, let's just break this down a little bit just so it's a little bit easier to read. We're going to add a new rule of resize, where the first thing I'm going to specify is C_crop, saying that I don't want to just scale it, I want to crop it. Then I'm going to say I want to specify the width as props.width, and I want to specify the height, the H, as props.height. And if we see what I did here, I used template literal tags so that I can dynamically pass those values in. But we also see that between each of these tokens, I have a comma so that we're delimiting that word, what we are actually passing in to the resize method. If we look at the browser, we can see that the aspect ratio for this image is drastically different. If we hover over and actually look, we can see that it's much shorter. And while that might not be perfect for what we imagine for mobile, we're going to be shipping less than half of the original image, which is going to save us huge for actually being able to deliver file sizes. But we have another problem here. While this is a really nice smile and a very adorable dog, we probably want the image to actually be centered on their face rather than just showing that smile on the dog. So what I can do inside of this resize method, I'm going to go to the very end, and I'm going to also specify G_face, which is saying that I want to set the gravity, or really the anchor point, to face, meaning it's going to focus the center of the crop at that person's face by using face detection automatically. And once we look at the browser, we can see we have a much better crop, and we can see their face right center inside of that image. Now, while probably ideally you can go through here and build a responsive part of this component, maybe you want to use the sizes prop of the image tag, or maybe you want to use a picture tag if you're going to actually change the aspect ratio of the image, or maybe just some CSS. But what happens if we are on a mobile device and we want to change it? Can we do that on the fly just the same? Well, the answer is yes. So all I'm going to do is change this 350 to 700. And again, while you probably want to build a more responsive component into this, such as a sizes prop, we're going to leave that as is for the sake of this example. And when we open up the browser, we can see that was already updated. It now has a great frame around the smile and the entire face, so that we can make sure that we're delivering as best as we can dynamically when we're trying to serve different image sizes for the different breakpoints on a page. We can even see if we open up the network tab, where before we were looking at something in the hundreds, we now have a file size of 78.9 kilobytes because we reduced and got rid of all that extra space we needed on the bottom of the image, but we were able to do all this on the fly. But once we're tapped into the Cloudinary API, there's a lot of things that we can do to make sure that we're delivering as best of an experience as we can with our images and as performant as we can so that we're not wasting precious kilobytes in size on people's devices. Astro is a great framework that gives us a lot of flexibility for being able to build performant websites the way that we want to build them. Couple that with Cloudinary and we can deliver all of our images and even our videos as performant as we can to avoid wasting bandwidth and delivering as great of an experience as we can. What's your favorite use case of Cloudinary? Do you want to see an official Cloudinary Astro integration? Let me know in the comments. If you want to learn more about the dynamic image sizing and the cropping and how we can use that face detection, kind of a little bit like what we saw today, check out my video, Generate Thumbnails Images Using Face Detection with Cloudinary. And while this is a Next.js video, the same rules apply to if you want to use it inside of an Astro app. If you want to learn how to use AI image recognition in order to automatically categorize and tag all of your images, check out my video, AI image recognition for auto tagging with Google Vision AI and Cloudinary. If you like this video, make sure you hit thumbs up, subscribe, and click that little notification bell for future web dev content. Thanks for watching.